In this video, let me start with the gaseous state. Okay, in earlier videos I have already discussed about the solid state and the liquid state. Okay, and in solid state we have learned that it is having a fixed shape and it has a fixed volume also, whereas in case of liquid state we have studied that liquid doesn't have a fixed shape but it has a fixed value. Okay, now in gaseous state we are going to learn that does it is have a fixed volume here. Okay, so the girl, she's asking, do gases also have a fixed volume? Okay, so that we are going to learn through this activity here. Activity 7.5, let us investigate. Okay, so in this investigation, what and all we need, take a 2 transparent gas jars, or we can say glass tumblers, and mark them A and B here. Okay, let me show you the picture. So like this kind of jars we need to take, and we have to label A, and another, it has been shown here, we have to label B for that. Okay, now in the next step what we need to do, create some smoke by burning an incense stick here. So here we need to burn one incense stick here. After that, hold the jar A upside down over the smoke. See here how we have to hold the jar. We have to hold upside down, means the open mouth of this jar, it should be at the down, so it will collect the smoke of this incense stick here. Okay, so and at one side it should be packed here, it should not be in the open, it should be packed. So one side we have to collect the smoke of this incense stick here. So after this, what we have to do, after collecting the smoke inside the jar, turn it over and cover it with a glass plate. So now we have to turn it over and we have to pack at the where it was open. Okay, with the help of glass plate here. Now hold another gas jar B upside down and gently place it over the glass plate covering the gas jar A here. After collecting the smoke, glass jar has been closed with the help of glass plate here. Now we have to take another jar that name has a B here. Now we have to hold in the again upside position on this plate of this jar A here. Now slowly we need to remove this glass plate here. So after removing, what will happen? Okay, we'll see. Now remove the glass plate slowly and ensure that the both gas jars are close enough that there is no gap for the smoke to escape. So we have to ensure that it should be exactly on the B. So it should not have any way to escape from this jars here. Which one? The smoke of this incense stick here. Okay. Observe how the smoke spread inside the gas jar B here. So after removing this glass plate, what will be having the smoke, it will be start going to this jar B. Okay, so that we need to observe here. Now the smoke fill the entire space in the gas jar B. So how much the space it will get? No, for the smoke it will cover entirely here. Now indicating that the gas do not have a fixed volume and tends to occupy the entire available space. Like liquids, they also acquires the shape of the vessel they are in. See, from this what we observe that wherever it is getting a space, no, it is completely occupying the space here. That they're only saying the smoke fills the entire space completely. It is entire space is now completely filled with the smoke in the jar B also. This indicates that gas also don't have a, gas do not have a fixed volume, but in the liquid what we have studied, it has the fixed volume. Okay, but gas doesn't have a fixed volume and it doesn't have a shape also obviously. Now tend to occupy the entire available. So what it is doing, wherever it is getting space for the availability, it is getting acquired. Now like liquids, they also acquire the shape of the vessels they are in, but in the liquids they will acquire the shape of the vessels that we have studied in here in this activity. So here it was in the bottle shape, and here it is acquires the jar shape, and here it acquires the glass shape. Okay, now this illustrates means this activity, it says that the particles in gases move freely in all direction and interparticles attractions are negligible. So from this what we can say that particles which is present in the gases, no, it will be moving freely in all direction, not only in one direction, in all direction it is moving. And since it is moving in all direction, it says that the attraction between the particles, attraction between the interparticles are very negligible or very less, or it is no also we can say. So since it doesn't have any attraction between the particles, that's why the particles are moving in all direction randomly here. As a result, gases do not have a fixed shape or a volume. So from this we can say that gases don't have a shape also, fixed shape, or either it doesn't have a fixed volume also here. Okay. In this activity, smoke is used to represent the gaseous state, right? We have used the smoke, that is incense stick here. The tiny particles of smoke suspended in the air are constantly hit by invisible particles of gases, and their movement help us to observe the motion of the gaseous particles here. Why we used here incense stick? Because that smoke we can see, right? And there are some invisible particles of a gas that we can't see also, right? But the smoke particles we can see. Why? Because there is a suspended smoke particles which is present in the air, and what it will be doing, this particle, let me show you it again. This is also what particle, this is also what particle. Just imagine this is the smoke particle and this is the invisible particle. So what will be happening? It will coming and it will be hitting. So when it will hit, it will go apart from each other. Again it will go and it will hit with another particle. Again it will go apart from each other. So like this the movement will be happening in the gas particles. Okay, this activity, this activity what we have studied right now. So this activity can also be demonstrated by using the iodine vapor instead of smoke from the incense stick. So what they're saying, this activity also we can done by using the iodine vapor instead of using the smoke from the incense stick here. Okay, now iodine vapor can be obtained by placing some solid iodine in the closed gas jar for some times, as shown in the figure. We have to place here iodine, solid iodine, and after in the closed gas jar, and after sometimes it will start vaporizing. So then again we can collect it another gas jar, like how we have done in the this activity on the above. Okay, now both liquid and gases flow and do not retain a fixed shape. These properties distinguish them from the solids and classify them as a fluids here. So we know that liquids and gases particles, what it will do, it will flow from one place to another place, whereas flow of rating gases in gases which is very high compared to the liquid. Okay, and do not retain a fixed shape, as we have studied with the activity. Liquids and gas don't have a fixed shape, whereas liquid at least it has a fixed value, but gas doesn't have a fixed value. Okay, and liquids and gases flow, okay, because of the fluidity of it character. So these properties distinguish them from the solids and classify them as a fluids here. Why it is fluids? Because it flow from one place to another place, that's why it classify as a fluids. But solids doesn't flow because that particles are very closely packed. That particle doesn't move freely, only it will be vibrating, that we have studied already. But in case of liquids and gases, particles are moving one place to another place. Okay, and in the gases which is very negligible, means it will be moving very randomly, and it will be moving very fast here. Okay, that's why liquids and gases has been classified as a fluid. How does the interparticle spacing differ in 3 states of matters, that we will be studying in the next video. Okay, thank you.